Okay, hello. Sorry about that. We are going to now be on day 2 of 3-5, which is scatter plots and trend lines. Okay, so today we're going to talk more about trend lines. A trend line is going to be placed on a scatter plot to help see the relationship or the correlation between data more clearly. Okay, it can also be helpful when we're making predictions based on the data. So it says here, use the trend line to predict how much money will be collected at the concession stand when 150 tickets have been sold. Okay, so here they have a scatter plot, a bunch of points there, and then they drew in a line. That's called your trend line, and you can see that it doesn't exactly hit all the points. A trend line is probably not going to, unless your data is really very close to a line. It's just going to kind of be a rough estimate of where this line should go so that all the points can get as close to the line as possible. Okay, so here we have tickets sold across the bottom and concession sales in dollars going up the top. So we're going to use it to predict how much money will be collected when 150 tickets have been sold. So for this, I'm going to be using a straight edge, okay, and I'm going to find 150 tickets being sold here. Now you can kind of see that we're counting by 20s, 20, 40, 60, 80, 100, right? So this right here is going to be 160. So 150 is going to happen like here on the x-axis. What I'm going to do to use this line to make a prediction is I'm going to follow this up to the trend line, and then I'm going to go over to the y-axis and see about what that value is. Okay, so right here is going to be the answer to the question. So I am counting by hundreds here. This is 100, 200, 300, 400. So this is going to be 700. So I'm somewhere between 7 and 800. So I think a $750 estimate is probably a good estimate. Now, of course, we're not all going to have the exact same number. It depends, because this is kind of an estimate, but we should all be around that number when we do this problem. Okay, use the trend line to predict how much money will be in Anthony's bank account after 65 days. Okay, so here is the scatter plot saying after 10 days he had like 245-ish dollars, and then he puts a little bit of money in there, and then he took some money out. You can kind of see it's negative, like it's going down over time, right? So this trend line, you can kind of see how they do it. They put about half the points on the top and half on the bottom. And since it's going down to the right, they're making this trend line down to the right. So the question is, how much is going to be in his bank account after 65 days? So here we're counting by 10 days, 10, 20, 30, 40, etc. So 65 days is going to be about there on the x-axis. So I'm going to just follow this up to the line, the trend line that is, and then I'm going to go over to my y-axis, and you can see it's in between 100 and 150, and that's going to be about $125 is a good estimate of how much money would be there after 65 days. Okay, so now that we've used the trend lines, we're going to try to draw our own trend lines and then use it to predict. So here are the steps, okay? So first of all, the first thing we have to do when drawing our trend line is determine if our graph is going to show a positive or negative correlation, okay? So looking here, you can see this one is positive. It's going up to the right. So that means my line is going to go up and to the right also. A negative correlation would mean our line would go down to the right, okay? So after that, so we've determined with this one that it's going to go up and to the right. Now it says ignore any outliers. So outliers are points that are like way off the line. Like, for example, if this one had a point over here, I would just ignore it, okay? Because a lot of time outliers they're just a weird scenario that happened, or sometimes it wasn't measured correctly. Okay, so we're going to use a straight edge to draw a line so that about half of the values are above the line and about half are below. And we're trying to stick to the points as closely as possible. So that's actually what I really want to focus on, because I have seen some kids draw their trend lines so that half are above and half are below, but it doesn't really make sense. So I'm going to draw one in pencil just to show you. So here's going to be a positive trend line where about half of the points are above and half are below. But this is not a good trend line. And the reason is because it doesn't closely follow as many points as possible. I want this line to like hit as many of the points as I can, okay? So I'm going to erase that. Not a good trend line. And I'm going to draw it so it's more in line with what the points do. Okay, and you can kind of see here that for me, I have most of them hitting the line. This one's a little bit above and this one's a little bit below, and that's perfectly fine. Is everybody's trend line going to be the same? The answer is no, okay? It's not going to be the same, but we should all be somewhat close. All right, for this one, I am going to put a little arrow on the end because that's probably going to go up and to the right. Okay, so here it says predict how many wrapping paper rolls need to be sold to raise $500. Okay, so the information they give us is $500, which is on this axis. So I'm going to find $500, which is here, and I'm going to use my straight edge to go over to the line, and then I'm going to follow this down. Okay, and you can see that I'm pretty closely between 50 and 100 rolls. So we're going to say that's about 75 rolls. Okay, so to raise $500, I would need to sell about 75 rolls of wrapping paper. Okay, again, is yours going to be exactly the same? It might or it might not be, but we should all be pretty close. Okay, the next one says, this scatter plot shows the number of orders placed for flowers before Valentine's Day at one shop. Based on this relationship, predict the number of flower orders placed on February 12th. So you can kind of see, based on the date in February, it's going up, right? That makes sense. The closer we get to Valentine's Day, the more flower orders are probably going to be placed. So again, this is going to be a positive trend. So my line needs to be going up and to the right for positive. And again, I want to hit as many of these dots as possible. Okay, and I was pretty much able to hit just about all of them on this graph. And we're going to use this to predict the number of flowers placed on February 12th. So here's the 10th, here's the 14th. The 12th is going to be here. So I'm going to follow this up to the line here. That's pretty much going to go right up to the top for me. And then I'm going to follow that over. Okay, and here we are counting by fives. This is 5, 10, 15, 20, 25, 30, 35, 40. This is going to be 45 right over here. Okay, so that's going to be about 45 orders. This would be helpful in a business so you can start to predict, how many flowers you need to order ahead of time and those kinds of things. Okay, the next one says to investigate whether speed cameras have an impact on road safety, data was collected from several cities. The number of speed cameras in operation was recorded for each city, as well as the number of accidents over a 7-day period. So first it says create a scatter plot of the data. So the x-axis is number of speed cameras. So I'm going to label that. And you can tell the number here, the lowest one is 3, and the highest number that we see, I think, is this 28. So I don't know what's appropriate. I might just count by tens, or really by fives. So this is 5, 10, 15, 20, 25, 30, 35, 40, 45, 50. Okay, I'm going to keep this. I'm just labeling every other one so it doesn't get so, jam-packed down here. All right, now I've got number of car accidents, and you can see that the smallest number that we have here looks like 19, and the highest number that we have is about 52. So I definitely need to get up to that number. So I'm actually going to count by tens here. So this will be 10, 20, 30, 40, 50, 60, 70, 80, 90, and 100. Okay, make sure that you're labeling your intervals so I know what you're counting by. Okay, and then we're going to label this as the number of car accidents. Okay, so now we have to plot all of these points. So the first one is 748. So here's 5, 7 is about here, 48 is going to be around here. Okay, 15, 35, here's 15 and here's 35. This one lines up perfectly on that point. 20 and 31 is about here. 3 and 52, we'll say is about there. 1640, 1735, 28, 1730, 2434, it's about here. 2519, 20 and 29, 5 and 42, 16 and 31, 25 and 21, 15 and 37, and 19 and 32. 19 is 32 about here. Okay, so you can see a lot of the points are clustered, and that's okay. The more data you have, the more dots you're going to have on your graph. So now I have to decide where my trend line is going to go. And as you can kind of see, it looks like these dots are sloping down to the right. So this is a negative correlation, which means as the number of speed cameras increase, the number of car accidents is going to actually decrease, because speed cameras is probably a good safety measure to help people slow down so they don't get in as many accidents. Okay, so I'm going to draw a trend line in here where we have about half above the line and about half below the line. You don't need to count, okay? It doesn't need to be perfect, but you just want to kind of estimate it. Okay, so now I'm going to use this graph. It says, let's see, that's part A. So B, draw the trend line. We did that. C is to use the trend line to predict the number of accidents there would be if 35 cameras were installed. Okay, so to figure this out, I'm going to take my straight edge again. 35 cameras is going to be here. So I'm going to follow this up to the trend line. And then I'm going to follow that over to the y-axis. Okay, and you can see it's somewhere between 10 and 20, a little bit higher than 15. So I would say around 16 or 17 would be a good prediction. So I would say probably about 16 accidents. Okay, that's all I have for you today. Let me know as usual if you have any questions.